In 1938, the infamous Munich crisis had just ended. Frederick George Miles made a major decision. He was the technical director at Phillips and Powys. He was also the chief designer for Miles Aircraft Limited. He decided to take his designs in a completely new direction. He shifted his focus away from pilot trainers like the Magister and the Master Mark I. Instead, he poured his energy into developing a brand new single-seat fighter. This new aircraft was meant to be a reliable backup to the legendary Spitfire and Hurricane. The ambitious project earned an unofficial nickname. People called it the Munich Fighter. The heart of the new fighter would be a powerful engine. It was a Rolls-Royce Peregrine engine. This engine would spin a two-bladed propeller. Visually, the aircraft stood out from its predecessors. It featured an inverted gull wing and a belly-mounted radiator. It also had a slightly scaled-down tail section. The designers also planned to equip it with retractable landing gear. It was not long before the team built a full-scale wooden mock-up of the proposed aircraft. In January 1939, they proudly showed it off to the Secretary of State for Air. His name was Sir Kingsley Wood. This took place during a grand opening. It was the opening of their new production facilities in Woodley, just outside Reading. Miles actually pitched 3 different wooden fighter concepts to the Air Ministry around that time. This was just one of them. The team put in a lot of hard work. The concept had a lot of potential. Despite this, no official government orders ever materialized. As a result, the project was shelved indefinitely. Things took a critical turn by the middle of 1940. There was a rapid German invasion of Holland, Belgium, and France. The writing was on the wall. The Luftwaffe might manage to gain total air superiority. If they did, Great Britain would inevitably be their next target. At that point, the Royal Air Force had a problem. They had significantly fewer fighters at their disposal than their formidable opponent. British pilots were taking fewer combat losses in dogfights than the Germans. However, they still faced a critical shortage. British factories might not be able to pump out Spitfires and Hurricanes fast enough. They needed them to replace those losses. Miles looked at this desperate situation. He realized there might be an unconventional solution. He proposed building a stopgap wooden fighter. The core idea was to build it using a massive number of off-the-shelf parts. These parts would come from aircraft already in mass production. Miles was convinced this pragmatic approach would be highly effective. It would allow them to build the new aircraft very quickly. They could build it twice as fast as contemporary metal fighters. Plus, the simple design had another benefit. It meant they could even be easily assembled in Canadian factories. He pitched the concept to the Minister of Aircraft Production, Lord Beaverbrook. He got an immediate green light. The minister issued a direct order. He wanted them to begin the detailed design and construction of the first prototype right away. He quickly drafted the necessary requirements. These were under Specification F-1940. All the hands-on design work for the new fighter was handed over. It went to a brilliant 26-year-old Swiss engineer. His name was Walter George Capley. His updated design kept the original M.20 designation. However, it was a major departure from the initial M.20-1 concept. This was true both visually and technically. Capley made a bold call. He used separate, much smaller, fixed main gear struts from Dowty. This was a brilliant move. It completely eliminated the need for heavy and complex hydraulic systems in the wings. He also ditched the complex inverted gull wing. This decision helped shave off some of the overall weight of the aircraft. Instead, the new straight wing was significantly thicker. It was much thicker than what you would see on a typical metal fighter. Take its thickness to chord ratio at the wing root. For comparison, it was 21%. A Hurricane sat at 19%. The sleek Spitfire came in at just 13%. This design had some significant advantages. They eliminated the complex retractable landing gear and used a thicker wing. This freed up a ton of valuable internal space. The military only asked for 8 .303 caliber Browning machine guns. But the engineers went a step further. They managed to squeeze in 4 extra guns. This brought the total to 12. They also packed in a massive ammo reserve of 5,000 rounds. On top of that, the fuel tanks on the M20 were impressive. They held 185 US gallons of aviation fuel. This was a huge step up over the competition. For comparison, the Hurricane fighter tanks were smaller. They were only designed for 115 US gallons. Meanwhile, the Spitfire could carry a modest 102 US gallons. Structurally speaking, the fuselage of this unique aircraft was made entirely of wood. The main airframe consisted of sturdy plywood components. These were carefully covered on the outside with doped aircraft fabric. The aircraft wing utilized the proven NACA 230 airfoil. Its internal structure featured two strong box spars and composite ribs. These were constructed from spruce and plywood. Just like the fuselage, the wings were skinned with plywood and tough fabric. This made the airplane incredibly easy to manufacture. Expensive and scarce metal was kept to an absolute minimum. It was mostly used just for the wingtips and the wing root fairings. The tail section and flight controls were built simply. They used the exact same wooden construction techniques. The designers wanted to give the aircraft maximum structural integrity in flight. So the stabilizer load-bearing elements were mounted directly to the main fuselage. The designers needed an engine for the new M.20 Mark II prototype. They chose a powerful Rolls-Royce Merlin 20 engine. It produced 1,300 horsepower. This same power plant was also being used on the Bristol Beaufighter Mark II heavy fighter. Interestingly, they made the engine installations entirely interchangeable between these two aircraft. There was only one noticeable difference. It was a slightly modified cowling shape. The standout feature of this project was the clear plexiglass bubble canopy. This design gave the pilot an unobstructed 360-degree view. It offered superior situational awareness. This was much better compared to other fighters of the time. To enter or exit the cockpit, the pilot simply slid the canopy forward or backward. They used a dedicated handle on the right side. In an emergency, the canopy could be instantly jettisoned. Safety was also a priority. The windscreen was made of armored glass 1.5 inches thick. A .3 5-inch armor plate was mounted directly below it. On top of that, there was extra armor behind the pilot's seat. This provided reliable protection for the oil tank. They wanted to finish work on the fighter as quickly as possible, so the development team worked around the clock with no days off. Their hard work paid off. This happened on September 15, 1940. It was just 65 days after starting the initial design work. Miles Aircraft Chief Test Pilot Tommy Rose took the M.20 Mark II on its maiden flight. On this flight, his colleague Hugh Kennedy accompanied him. Kennedy was flying a Miles Master chase plane. Soon after, Kennedy himself took over the regular flight testing of the new aircraft. He evaluated its handling characteristics and performed demonstration flights. The new aircraft delivered some truly impressive performance numbers. At an altitude of 22,600 feet, the fighter reached a top speed of 333 miles per hour. Its initial rate of climb was 3,200 feet per minute. These numbers were achieved thanks to a smaller wing area. This naturally increased the wing loading. However, because of this, the airplane required a longer takeoff roll. It also had a higher landing speed. This was higher compared to the legendary Spitfire or Hurricane. With the flaps down, the M.20 Mark II had a takeoff roll of 810 feet. Its stall speed was 80 miles per hour. If the pilot opted for an economy cruise power setting, the aircraft had a range of 550 miles. This allowed it to stay airborne for about 2 hours. Once the basic handling checks wrapped up, they rigged an anti-spin parachute to the tail. They kicked off the most dangerous phase. This was spin testing. That is where they ran into a major problem. The fighter was incredibly reluctant to recover from a spin. During one of these flights, even deploying the anti-spin chute did not help. Hugh Kennedy was actually getting ready to bail out. Then, the M.20-2 miraculously recovered on its own. To figure out what was going on, the engineers put a scale model in a wind tunnel. They found out that during a spin, the horizontal stabilizer was completely blanking the airflow to the rudder. They came up with a pretty clever fix. The team extended the rear fuselage. They also moved the horizontal stabilizer a bit further back. By late October, the airplane got a new paint job. The upper surfaces of the wings and fuselage were painted in a standard camouflage scheme. The underside was painted bright yellow. This color was usually reserved for training aircraft. Flight testing continued smoothly right into the winter of 1941. But in early February, there was a major mishap. Kennedy was coming in to land on a snow-covered airfield at Woodley. This happened after a routine climb performance test. When he applied the brakes, the wheels locked up instantly. The aircraft essentially turned into an uncontrollable sled. It skidded completely across the airfield and tore through a metal fence. It crashed nose first right into a flooded gravel pit. Luckily, the pilot walked away without a scratch. But for the airplane itself, this was the end of the line. It is very likely that this crash officially ended the M.20-2 flight test program. On top of that, the toughest phase of the Battle of Britain was already over, so the desperate need for an emergency mass-produced fighter had pretty much faded away. However, the story of the project did not necessarily end right there. Back in late 1940, chief designer Frederick George Miles had actually pitched a new variant to the Air Ministry. It was a fighter-bomber version called the M.20-3. The idea was that this fighter could carry an extra drop tank or a bomb. This would be a 50-gallon tank or a 500-pound bomb under each wing. Hauling that kind of extra payload would have increased the wing loading. It would go up by another 2 or 3 pounds per square foot. But calculations showed the airplane would still take off with plenty of margin. The idea was very promising. The team was also very enthusiastic. But the top brass never threw their support behind the initiative. In the end, the project remained nothing more than an ambitious idea on paper. By early April 1941, an updated version of the aircraft rapidly took to the skies. This was the M.20-4. Historical records suggest an interesting fact. This was most likely the damaged M.20-2 prototype. It was completely rebuilt on the personal initiative of Frederick George Miles himself. He did this specifically to counter a new and very serious German threat. Official paperwork actually backs up this theory. The contracts listed the exact same data as the previous model. Because of this, it is pretty safe to say that the new fighter was not built from scratch. It was instead cobbled together. They used a lot of parts from its predecessor. The primary threat at the time was coming from Germany long-range bombers. These were the FW-200 Condors. These formidable bombers were relentlessly attacking Allied shipping convoys. They struck out in the western approaches and off the northern coast of Ireland. In a desperate bid to counter these attacks, British command came up with an unconventional idea. They decided to outfit standard merchant ships with what were basically disposable fighters. These aircraft would be launched directly off the deck of the ship. They would use a special catapult system. This allowed them to quickly intercept the incoming enemy bombers. The problem was that after completing a combat mission, the fighter simply could not land back on the merchant ship. So the pilot had to bail out near friendly ships. He just had to hope he would be spotted in time and rescued from the freezing water. Given this mission profile, a disposable fighter did not need landing gear at all. Plus, omitting the wheels made the airframe lighter. It also significantly improved its flight performance. Of course, a fixed landing gear was still fitted temporarily. This was just for initial ground tests and pilot training. It allowed them to safely get comfortable with the new aircraft. Looking at the technical details, the landing gear struts on the M20 Mark IV model were noticeably different from earlier versions. The engineers significantly reduced the size of the wheel fairings. This was done on purpose to minimize drag. It helped evaluate how the aircraft would handle in actual combat. This was important for when the landing gear would be completely jettisoned. The design did not include an arresting hook for carrier landings. The nose of the aircraft was made much sharper than on the M20 Mark II. The cockpit canopy was also reprofiled. However, the engineers kept the distinctive exhaust pipes with flame dampeners. These were borrowed from the well-known Beaufighter Mark II. Special catapult spools for ship launches were located on the lower fuselage. They were right under the cockpit. In July 1941, the Ministry of Aircraft Production officially approved the specification for this aircraft. The fighter was given a working title. It was the Miles Single-Seater Fighter for the Fleet Air Arm. According to official documents, there were very strict requirements for this wooden fighter. It was tailored specifically for the needs of the Navy. The aircraft had to feature a one-piece wing design and fixed landing gear. The primary requirement was that the gear had to be easily jettisonable. The aircraft itself had to fly perfectly fine both with and without wheels. On top of that, the airframe had to withstand massive structural loads. These came from a hard catapult launch and emergency deceleration. This meant that a conventional carrier deck landing was treated by the engineers as a secondary contingency. It was not the primary one. They expected some serious performance from the aircraft. Top speed at sea level had to be at least 300 miles per hour. This was true even with the landing gear and braking systems installed. Its service ceiling had to reach 20,000 feet. Cruising at 15,000 feet, the aircraft had to remain airborne for a full 2 hours. As an alternative, it could fly for 15 minutes at wide open throttle right on the deck. As for the armament, it packed a serious punch. It had 8 powerful Browning machine guns. Each came with a 500-round ammo box. The pilot would have to bail out over the ocean, so the design absolutely had to include a parachute. It was integrated right into the seat. It also needed a compact inflatable dinghy for water survival. Once all the necessary approvals were in, test pilot Hugh Kennedy began the first flight tests. This was on the M.20 Mark IV fighter on April 8th. A rigorous test flight program went on for several days in a row. After that, service pilots took the controls. By mid-April, the aircraft was sent to the highly classified Boscombe Down facility. Specifically, it went to the Aeroplane and Armament Experimental Establishment. There, the aircraft went through its final operational trials. These were the most grueling. It then received its official evaluation from military experts. During the development and early operational phase of the M20-4, engineers and pilots had plenty of complaints about its design. For instance, the emergency canopy release mechanism was described on paper as extremely well thought out. However, in practice, it was virtually useless. To actually operate it, the pilot had to pull the release handles with both hands simultaneously. In a cramped cockpit, doing that was nearly impossible. Pilots wore heavy flight gloves. Because of this, they could not physically fit their fingers through the release levers. The cables connected to the locking pins kept snapping. This made the entire mechanism a nightmare to deal with. What is more, the designers did not even include an external canopy release. Opening it was a struggle even under normal conditions. So test crews realized a major problem. In freezing temperatures, the canopy would just freeze completely shut. Getting into the cockpit was a hassle too. There was not a single handhold or step on the fuselage to help the pilot climb onto the wing. Because of this, pilots and mechanics had to step directly on the left wing root. This constantly damaged the metal fairing strip. The fuel system also had some major flaws. There was a severe lack of drain holes on the lower wing skin. Also, they did not install any seals between the fuel tank filler neck and the upper wing skin. Any spilled fuel could easily seep inside. This could seriously damage the internal wing structure. The fuel tank vent lines were located right on the lower center line. This was on the fuselage. They constantly ingested oil from the engine compartment. Eventually, they got completely clogged. The oil tank cap did not seal properly either. Oil leaked directly into the fuselage. This degraded the adhesives. It also soaked vital electrical wiring. As for the drainage system in the wooden wing, evaluators wrote it off as completely ineffective. For the mechanics, maintaining this aircraft was an absolute maintenance nightmare. The original duralumin flap hinges wore out quickly. The upper engine mounts were basically impossible to reach. All the inspection panels were screwed down with standard machine screws. They did not use quick-release fasteners. This added a ridiculous amount of time to basic maintenance. On top of that, the hinged access panels did not open fully. Mechanics had to prop them open with one hand, then they had to try to work with the other. To get to the aft oil valve, you needed a special extension tool. This was because the valve itself was buried deep within the airframe. The aircraft was expected to operate constantly. This would happen in damp maritime environments. Engineers heavily criticized the extensive use of magnesium alloy parts. These parts were highly prone to corrosion in such environments. The clearance between the tailwheel fork and the tire was very tight. Mud constantly packed into the gap. This locked up the wheel. The evaluation board strongly recommended installing a sturdy roll bar. This was to protect the pilot in the event of a rough emergency landing or a nose-over. Because of constant engine problems, flight testing experienced significant delays. Still, on May 24th, engineers finally released their first report on the handling characteristics of the aircraft. Pilots once again complained about the lack of footholds. However, they found the actual process of climbing into the cockpit to be pretty manageable. Once they got inside, they were not exactly thrilled. It turned out the pilot had to sit virtually on the floorboards. Their legs were stretched straight out. On top of that, the pilot had to wear a backpack-style life raft. All subsequent test flights required flying with it inside that tight cockpit. The floor was so close to the rudder pedals that heavy flight boots simply would not fit under them. Engineers had to scramble to find a compromise. They had to either lower the floorboards or raise the rudder pedals. Despite this long list of flaws, the aircraft had its redeeming qualities too. The bubble canopy earned high marks from pilots for its superb all-around visibility. Evaluators also pointed out that having armored glass was a critical advantage for actual combat operations. The overall instrument layout in the cockpit was considered a success, but the designers were heavily criticized for omitting a reserve fuel tank. This added unnecessary risk to combat missions. During testing, the M.20-4 flew at a recommended gross weight of 7,560 pounds. Instead of cameras and radio equipment, ballast was loaded on board to simulate their weight. Engineers noticed a critical trade-off during the flight tests. With a full load of ammunition, the aircraft was heavy. It only stayed within its maximum gross weight if it carried no more than 110 gallons of fuel. Because of this, the evaluation board made a decision. They decided it made much more sense to sacrifice some ammunition capacity. This would increase the range of the aircraft. Ground handling turned out to be fairly straightforward. However, the original brakes notoriously lacked stopping power. This issue was eventually solved by installing new wheels and brakes. These remained on the aircraft for the rest of the test program. During takeoff, another quirk emerged. The airplane had a severe left-turning tendency. To maintain center line down the runway, the pilot had to apply opposite rudder all the way to the stops. If that left yaw was allowed to develop, correcting it became impossible. On top of that, even with the recommended 30 degrees of flaps, the takeoff roll was uncomfortably long. The flaps themselves were also problematic. They retracted far too slowly. They also did almost nothing to increase the descent rate. They also produced no noticeable pitch change when deployed. Initial flight tests showed that the aircraft was stable across all three axes and at any speed. However, control forces were heavy, while the ailerons were overly sensitive. This became especially apparent when diving in turbulence or flying at low speeds. In smooth, straight, and level flight, the control stick would oscillate fore and aft by about 2 inches. However, it took very little pilot effort to stop it. Flight testing near the edge of the envelope revealed the following characteristics. In a clean configuration, the flaps were up and the stick was near neutral. In this state, the M.20-4 would lose lift. It would drop into a spin at 90 miles per hour. Right before the stall, a light airframe buffet provided a warning to the pilot. After this warning, the fighter abruptly dropped the nose. It then rolled hard onto its right wing. At this point, those overly sensitive ailerons became almost completely ineffective. Large control deflections were needed to get any response. With the flaps down and the stick held aft, the stall speed dropped to 73 miles per hour. In this configuration, however, the stall broke with almost no warning. There were very few warning signs. They included a high-pitch attitude and the tendency of the aircraft to sharply snap roll to the right. If the pilot failed to react in time, the fighter would drop the right wing. Overall, control response was similar to the clean configuration. The elevator and rudder remained fully effective. When the M.20-4 was pushed over into a 450 mile per hour dive, test pilots described its acceleration as simply outstanding. Additionally, the cockpit was incredibly quiet. There was a lack of loud wind noise around the canopy. This made the sensation of immense speed surprisingly comfortable. The peculiar behavior of the ailerons showed up again here. With light inputs, they were far too twitchy. But under heavier deflection, stick forces increased moderately. This happened without any nasty aileron snatch. In the dive itself, the aircraft tracked straight and true. Dive recovery was smooth and predictable. Basic aerobatic testing also went smoothly. However, the test pilots noted once again that the fighter was heavy on the controls. The test pilots paid special attention to the high approach and landing speeds. To fly a safe approach, the aircraft had to maintain around 100 miles per hour. It touched down at 80 miles per hour. Engineers also highlighted a serious issue. The fixed landing gear could become a death trap during an emergency landing. This was especially true without a dedicated roll bar to protect the pilot head. The report stated bluntly what would happen if the engine quit. If there was not a large, flat field nearby, the pilot faced a tough choice. They had to either bail out immediately or attempt a forced landing. The landing would be at great personal risk. Alongside the main flight testing, live fire weapons trials were also underway. This phase began back on April 26th. It lasted until July 20th when engineers decided to briefly pause flight testing. No satisfactory firing results had been achieved by that point. Because of this, they had to start the weapons testing over from scratch. A new testing cycle successfully wrapped up on July 29th. The final report was issued on August 21st. Each wing housed 4 Browning machine guns. They were equipped with a pneumatic charging system. To access them for maintenance, mechanics had to open large, hinged panels on the upper wing surface. The ammunition boxes for both the inboard and outboard guns were mounted tightly side by side. The aircraft first arrived at the test center. At that time, each of these boxes held 600 rounds per gun. But during a detailed inspection, armorers noticed an interesting detail. The inboard boxes had a false bottom. Once removed, the capacity instantly jumped to 900 rounds per gun. Interestingly, this increased capacity was a problem. It completely violated the original design specifications. Those specifications strictly limited the ammo load to just 500 rounds per gun. The rearming process itself turned out to be fairly simple. It only took 2 armorers about 20 minutes to complete the job. It was expected that this turnaround time would drop even further with practice. The machine guns were just as easy to remove for cleaning. That took another 20 minutes. Completely replacing them required no more than 25. However, removing the blast tubes and opening the gun bay covers was difficult. It required special tools. Yet, for some reason, the designers did not include any stowage space for them on board the aircraft. During ground firing tests, engineers discovered a whole series of major flaws. In total, they fired over 27,200 rounds. The problems just kept piling up. For example, the ammunition box guide rails failed. They did not properly secure the stiffening plates. This caused the entire assembly to vibrate and the ammunition to jam. On top of that, there was another issue. The gun bay covers kept snagging on the feed chutes. This threw off the alignment of the ammo boxes. As a result, the ammunition belts would simply bind up at the worst possible moment. As for the feed chutes themselves, they were either manufactured very carelessly or poorly installed. Some of them warped directly into the path of the ammunition belt. This prevented the guns from feeding. The pneumatic trigger mechanism was also acting up. When the pilot pulled the trigger, there was a problem. There was often a significant lag. This caused the machine guns to stop firing. Their bolts would be stuck in the forward position. Gun heating added another headache. Hot air was piped into the gun bays directly from the engine exhaust stacks. Engineers rightly pointed out a big issue. This hot air would keep the barrels from cooling down properly. It would also lead to severe overheating of the actions. This could have easily become a critical issue. It could trigger excessive metal wear and extremely dangerous cook-offs. To fix this, they recommended modifying the design. They suggested feeding fresh air directly to the machine gun breeches. Fortunately, most of these teething problems were quickly sorted out at the test center. They brought in specialists from Dunlop and Phillips and Powis. Working together, they sorted out the temperamental pneumatics. They brought the stoppage rate down to a perfectly acceptable level. The next step was low-altitude testing. Here, pilots fired off an impressive 62,000 rounds. But the problems came right back. The guns kept stopping due to feed issues or jamming. Even after the initial tweaks, the weapons still jammed. This happened often. It occurred whenever the pilot fired during steep turns or slips. It turned out there was an issue under high G loads. The ammo was shifting around inside the boxes. This prevented the belts from feeding smoothly. They came up with a pretty clever fix. They installed special partitions inside the ammo boxes and added springs to the lids. This held the belts securely in place and kept them from sliding into the empty space. When it came to harmonizing the machine guns, the options of the armorers were severely limited. The problem was that the cooling tubes could not be installed or removed if certain guns were dialed to their maximum adjustment limits. The guns had a wide range of elevation overall, but the design still made it completely impossible to align them. They could not match the recommended harmonization patterns. As for cockpit ergonomics, forward visibility was actually quite good. This was especially true when compared to other single-engine fighters of the era. However, the test pilots unanimously demanded a height-adjustable seat. On top of that, the heavy windshield framing seriously obstructed accurate aiming during combat. Rear visibility, on the other hand, was absolutely fantastic. It made it easy to check your 6 and spot an incoming bandit early on. Flying the M.20-4 while tracking a target was pretty comfortable. But there was one glaring issue. The directional stability of the fighter was practically non-existent. Pilots had to constantly ride the rudder. This happened because of how the aircraft handled during hard maneuvers. Any change in airspeed or throttle immediately threw off the yaw trim. Firing the guns caused the nose of the aircraft to pitch down slightly. Luckily, this tendency was easy to compensate for. It barely interfered with keeping the target in the reticle. Using the gun sight and its tinted screen was straightforward and comfortable. The sight itself barely vibrated in flight. However, the reticle illumination was woefully inadequate. It fell well short of accepted standards for the time. Once the test center engineers pushed through a series of design changes, the weapon system was finally cleared for combat. However, the aircraft itself left a mixed impression. Test pilot William Pete Whitworth was flying gunnery trials. He was over Sidmouth Bay on July 24th. He recalled that the M.20-4 just was not popular with the pilots at all. The main culprit was its highly problematic Merlin engine. It was constantly making strange noises. It rattled and knocked for no obvious reason. Meanwhile, the ground crews were completely stumped. They just could not figure out how to tune the temperamental power plant.